Welcome to Notebook 14, Streaming and Batching. In this notebook, you're going to learn how to stream model responses and also to handle multiple chat completion requests in batches. By the time you complete this notebook, you will learn how to stream model responses, learn how to batch model responses, and will actually compare the performance of batch processing to single prompt chat completion. As we did in the previous notebook, and pretty much will be doing for all subsequent notebooks, we're going to import Chat NVIDIA from the LangChain NVIDIA AI Endpoints library. Using the same base URL and model string as before, we're going to create an LLM instance using the Chat NVIDIA class. Again, we'll be setting the temperature to 0 to give us reliable deterministic model responses. And just as a sanity check, since we're still really just warming up using LangChain, we're going to create a simple prompt and we're going to use the invoke method and just confirm that the large language model is still invocable. Now, using invoke, as we just did, and also we did in the previous notebook, what you may have noticed is that there's a slight pause, right, while we're waiting for the model response, and then the entire response is pretty much printed at once, right? And this is what it means to invoke. We wait for the entire response before providing it into the coding environment. But as an alternative to the invoke method, we can also use the stream method. And in doing this, we receive the model responses in chunks. In this way, you don't have to wait for the entire response to be generated, and you can see the output as it's being produced. So especially for long responses, or especially in like user-facing chatbot applications that you might build, streaming output can result in a much better user experience because you see the responses being created as they're being generated, as opposed to having to wait for the entire thing. So let's create a prompt that's going to require a slightly longer response than what we've seen before. We're asking the model again to explain who it is, but this time we're specifying in roughly 500 words. This isn't super long, but it's long enough that it'll make a difference if we stream it or not. So the good news is the LLM instance that we've been using, that we created with Chat NVIDIA, just like the invoke method, it has a stream method that we can invoke, and we pass it a prompt. The only difference is now we're working with streaming, and rather than returning a single response, this stream method is going to return a generator, a Python generator. And as you probably know, we can loop or iterate over generators. In this case, we're going to call every item that the generator returns a chunk. And just like we did on the invoke method where we looked at just the content field specifically, we're going to look at the content for each chunk. And then usually when you use the print function, a new line character is appended to the end of the response by default. But we're going to override that and say that the final character for each chunk should just be an empty string. And in this way, we don't have new line characters in between, sentences or parts of sentences, etc. All right, so let's take this for a whirl. And you can see here, we got our 500 word, roughly 500 word response back, where again, the model is explaining who it is. But this time, as you saw, right, we can run it one more time. Instead of waiting for the entire response where it's kind of dumped at once, we're printing every chunk as it comes back. And using this stream method, we're able to interact with the server in a slightly different way and get a streaming set of responses back. Okay, so again, in certain kinds of applications, this kind of use can be very, very, very handy. So in addition to the invoke method and in addition to the stream method, there is also the batch method. And what the batch method allows us to do is call the model with a list of input prompts. So instead of just sending a single prompt and getting a single response, we send in a list of prompts and get back a list of responses. The responses will be in the same order as they were passed in. So, not only is batch convenient when working with collections of data that all need to be responded to in some way, which as you'll see in many use cases in this course is going to be natural and even necessary. But the batch method is also designed to process multiple prompts concurrently whenever possible, effectively running the responses in parallel, again, as much as is possible. So this actually allows for a more efficient handling of multiple requests and reduces the overall time needed to generate responses for a list of prompts. By batching requests, you can leverage the computational power of the language model to handle multiple inputs simultaneously, improving the performance and throughput. Kind of put another way, large language models cannot handle unlimited input at once, but they are able to handle a certain amount of input at once. And there's a good chance that whatever prompt you're sending it is not actually utilizing the large language model to its fullest capacity. So when you batch inputs, if it's possible, then under the hoods, the programming will take care to allow the large language model to use itself to its fullest capacity and process as much of the information as possible in parallel. And this can result in better performance overall. So let's demonstrate it. We've created a Python list of prompts here. They're all basically just asking what is the capital of a specific state. And now using the batch method on LLM, right, we're going to pass it in a list of prompts. And in doing that, we have a response back, capitals. You can see that happened really quickly. The length of capitals is 6, which is the same length as our state capital questions. And if we loop over each of the items in our capitals responses and look at the content field for each of them, you can see in the same order, we got the capital of California, Texas, New York, Florida, Illinois, and Ohio, right? So one thing to note, perhaps you weren't already thinking about this, but some people might think that when we send in batch requests, because maybe they're used to working with a chatbot application like ChatGPT, it's not the case that there's some sort of conversation, multi-turn conversation happening, right? It's not like we're asking for the state of California and then the model sends us a response and remembers that first one, and then having known what it responded to with the first prompt, then responds to the second prompt. No, these are all atomic units. They're being sent individually. I mean, they're being processed in parallel, right? But in terms of the model's understanding of what's being asked and in terms of the model generating a response, that logic of the operations is happening discretely and separately between each of the prompts. So we made the claim earlier that this can result in some performance benefits. So let's see if we can prove that a little more concretely. So we're going to use a bit of, it's called magic in the Jupyter world, where we're going to use a certain kind of magic called time. And we do that by providing these two percentage symbols and then putting the word time. You could write your own Python code using the time library, etc. But basically what this is going to do is it's going to run this particular cell and give us some output about how long it took. And the item that we're actually most interested in is the wall time, which you can see here is 178 milliseconds, right? So this is the same call we made above. We haven't bothered storing this in a variable and printing over it and getting the content out, which is why we have a list of long form responses. Okay, but the main takeaway is the batch took 178 milliseconds. If we time this cell's execution, where instead of using batch, right, we're just going to loop over our state capital questions and use invoke for each one of them, right? So in some ways we're doing the same thing, right? We're sending in 6 prompts and we're getting back 6 responses. But in this case, by doing them individually, it took 710 milliseconds, which is really quite a drastic slowdown compared to 178 milliseconds. So again, this is a little bit of a simple way to show more quantitatively that when we use batching, when it's appropriate, when we use batching, we can get real performance gains instead of just looping over a list and sending individual prompts to the model. And again, this is because oftentimes the model is able to process more than a single given prompt requires it to process. So it can process multiple prompts at the same time. Okay, so we've got an exercise for you using the batching method. And I think this exercise is still pretty straightforward, but it's starting to get pretty cool because, it's not much, but you're going to see just through this simple exercise, you're kind of already able to do something that maybe someone at your organization or you yourself have had to do kind of manually or by yourself. So you're kind of going to start to see already that there's a lot of low-hanging fruit in terms of applications or tooling or useful use cases that you can get a large language model to help you with in your organization. So what is the exercise? We're going to use batch processing to respond to a variety of questions. In this case, they just happen to all be large language model questions. And the idea in this exercise is that we're going to create an FAQ document. Yeah, we're going to create an FAQ document. So here's a list of questions. There's roughly 10 of them. I'm not going to count them, but your job is to populate an FAQ answers list. We've provided that for you here. And it needs to be populated with a response to each one of these questions. And you're highly encouraged to use the batch method to make this super, super easy. Probably you are already saying to yourself, oh, I got this, no problem. And upon successful completion, you should be able to use this helper function, create FAQ document, to which you'll pass in the FAQ questions and the FAQ answers. We're basically just going to do a little bit of string formatting here to return an FAQ document. So after you successfully populate FAQ answers, you should be able to run this cell here and get a successful printout. So feel free to pause the video here and then come back after you finish the exercise and we'll take a look at the solution together. Okay, hopefully that was really straightforward to you, and it's my hope even that in doing that simple exercise, maybe you've already started to come up with a few ideas about like, oh, gosh, I've got collections of data or collections of prompts that I need batch processed. So yeah, let's take a look here. We open up the solutions. We're going to say that FAQ answers is equal to the result of batching the FAQ questions. Excuse me, I think I failed to define this up above. This one is taking a little time. That's all right. We're probably generating a lot of text here. And now this is the same create FAQ document helper as above. And if we print it out, you can see here, you know, what is a large language model, right? This is our first question. And we've made a nice little printout here. This is all entirely generated from the large language model itself. The next item is how do LLMs work? And we've got a response to that here, and et cetera, et cetera. And just like that, I mean, we've got ourselves a somewhat lengthy FAQ document that, you know, at the end of the day took us one line of code and, you know, a few seconds to put together, which is really cool. Okay, we're going to be using batching when appropriate on numerous occasions throughout the course for sure. Okay, yeah, so in this notebook you learned how to batch and also how to stream model responses. And furthermore, you created a helpful FAQ document. In the next notebook, you're going to begin focusing more heavily on the creation of prompts themselves, with an emphasis on something we're going to be calling iterative prompt development. And furthermore, we're going to talk about the idea of engineering prompts that are very specific. So we'll see you in the next notebook.